Perfect. Thanks, Gary. Um, so cool. So um, I'll start by saying thanks. Thanks for joining, and also I'll give a couple of words about myself before I start. I'm Liav. I'm the CTO of a security company called Legit Security. Maybe at the end I can talk a little bit about the name. Um, but the focus of Legit is to secure development pipelines. And we've been doing a lot of research into what secure development should look like. I'm working with large organizations, so we have encountered a lot of examples and a lot of data around how organizations try to release application and try to do it securely. So in this beginning session, I will start by talking about what are some of the challenges in building secure SDLCs. Hold on. Sorry, the control of the screen was a little bit slow. Before that, I have a background of, I think, more than a decade doing cybersecurity, but then also I built the SCA solution in checkmarks before that, following a startup acquisition. So for many years, me and my partners have seen a lot of teams try to do application security. So going into the world of application security, then, as Gary said, feel free to, if there is any question that pops up, feel free to write it and we'll answer this at the end. Application security is still not working. There's still a lot of problems. I brought here like 3 numbers that represent part of the problem. But first of all, there is a large number of incidents categorized as supply chain attacks. Some of them are just malicious libraries. Some of them are code that's being stolen. But the common denominator is that the development environment is being hacked. And this is going and increasing in numbers. There's some prediction numbers, but in the last 12 months, at some period last year, there's been 61 of the US-based organization reported they were directly affected. Another statistic that we see is that the development environment is full of sensitive data. And actually, this is getting more and more sensitive as development progress. So now to release an application, you need dozens of passwords and API tokens. And we've seen that every week we see almost 12 live secrets getting into the code for every 100 repositories, which is a lot. So as time goes by, a lot of sensitive data is being exposed around there and up for grabs for attackers. And then the last piece of information is that there is a lot of vulnerabilities, a lot. So there is more than 100,000 vulnerabilities, and sometimes in millions, open in many of the organizations. And there's still a lot of problems, and eventually what you see is that pipelines are being hacked, code is being stolen, and applications are still released with vulnerabilities. What I wanted to talk about in this session is a little bit more about why this is happening. What are some of the trends that lead to that? One thing I also mentioned that the regulations and the requirements are getting more and more tighter. So since SolarWinds, a chain of regulatory incidents led to a lot of different requirements. So if you happen to hear about this or not, then the US government is requiring a lot of signatures and evidence and documents by everybody selling software to that. By the way, one of our employees was in a NIST, the National Institution for Standard Conference in the States, and the US government mentioned that they are, what they do with the data that are being provided, they're actually looking for ties to different, to China, to Russia. They're looking for ties to different third parties. they're actually reviewing everything provided to them, but they're actually requiring a lot of information from everybody selling software to them. SBOM is another requirement, that the list of ingredients is required. There's a lot of problem on, a lot of regulations about software security from every almost compliance framework that looks at how secure is software developed, just because it's a problem. And part of the problem is that with the change into development pipelines, basically you have an automated system that produces changes. Amazon once shared a statistic that they're doing more than 1,000 changes in the runtime environment. I think it was per hour. So imagine how many changes are happening today in an average bank that wants to move quickly. So this is a sort of like we call sometimes the highway to the cloud. This is an automated system that changes the posture of the application many times every day. It's sometimes it's automatic. Sorry for the slide change. Hold on. It's automatic, and part of what I'll be talking about is that it's not something that could be done manually. So there is an automated process that changes the posture of the application in a continuous way. There is a lot of systems, a lot of tools, a lot of moving pieces, and it's going to be very hard for any individual to get a hang of this without some help. And this is also part of the reason why we see a lot of things going wrong. If we look just in general from a high-level perspective, there has been a lot of trends in software development that led to that. So some of the things that on a kind of like what changed section, agile is a fact. If you read the state of agile report, you'll see that there's like 80% of organizations do agile today, and even more. The concept of continuous integration, continuous delivery. Most of the software today, or a lot of the software produced by organizations, is software as a service. It goes to the cloud. It takes the form of microservices. So it's software that is available on the internet for millions of users. We have, as an industry, complete dependency on third-party software. So if you think about let's say you're developing JavaScript and let's say NPM is down, it's basically denial of service for the organization for some time, unless they have like a shadow copy of that for some time. Or GitHub. If GitHub is down, then it takes back the ability to develop new capabilities and new features, because it's a repository of most of the building blocks that are being used today to develop software. Everything is code. So the cloud configuration are code. A lot of everything becomes code. And then the last thing is AI, which I don't think we really understand. I heard the term recently, like English is going to be the next programming language. So I don't think there is still an understanding of how AI is going to impact software development. But all these things lead to a situation where developers make more decisions. So they're now making decisions about cloud configurations. They decide on what third parties to include in the product, in the application, how to configure it, what to expose. The attack surface of what an attackers can get has increased. So there is more APIs, more surface area. Almost every entity involved in the process can be scanned for vulnerabilities. And as an industry, we're very good at finding vulnerabilities. There is tons of scanners for every type of like for containers and for source code that can, if you just run them, even open source tools, you'll find tons of results, hundreds of thousands or millions. So what do you do with it? And then the composition of an app is so complex. Then if you'd like to understand, hey, I have a problem in a code file, what does it affect? What's the problem? Is it part of my website, my mobile app? Is it internet facing? What does it represent? It's a hard question to say sometimes. It's a little bit of an ironic situation, but it's like You have a house, but you're not sure what it was built from. So you have to like kind of start to understand like, how did I build this? How did I get to this situation? There is an increasing number of incidents. Log4Shell is a famous one. Log4j. Covered this before. I want to stop here before I go into a couple of more technical use cases. I want to touch. I want to touch like the definition of secure software development lifecycle, and there's three components that I think are important to bear in mind, because this is a phrase that's thrown out a lot. So the first category is we want to build secure software. So we want to make sure that the changes we're introducing to the software, the code we're writing, is secure, doesn't contain vulnerabilities. That's the first item of a secure software development lifecycle. And I'm talking about like the development process. So how can we make sure we're developing or making changes that are secure? The second thing is secure the software factory itself. So imagine this is a car factory. First item is I want to get secure cars. The second item is I want to get the car factory secure. I don't want anybody getting in and temper the cars, stealing my blueprints or doing anything with it. So it's more around the security of the facility. And the third thing is more around how do you identify and fix things as a process. So you could have the perfect and secure application, but then one day you'll get an email saying a new vulnerability was discovered that you never know about, a 0-day that somebody discovered. And now it's affecting your application. So how can you react to that? How can you respond to something that at some point you didn't know was a problem, but now it's been discovered? And this is the assumption, like not all vulnerabilities will be discovered at build time. So how can we fix things that we discover sometime afterwards or being reported about in an effective way? So these are like the three problems of secure development lifecycle. Just to go a little bit technically, I just want to demonstrate a little bit how complex is the build pipeline and how many points you need to take into consideration when securing a designing a secure pipeline, sorry. So a single code change, for instance, can go through, let's say, code repository, can be built using a build tool, can turn into a container, and then be deployed to the cloud, which is, a very, very basic construct. It could be that I've got problems in my source code. It could be that I've got problems in my Jenkins servers. So, for instance, I'm not performing any reviews, which is a problem. Nobody sees the code. There could be vulnerabilities. Maybe AI generates the code, another person. And also, the Jenkins could be wide open for everybody to grab it. There is a lot of things I can introduce. I can introduce code review as a step and require this as a famous configuration called branch protection. But now there might be another complexity that was introduced. My code depends on libraries, maybe thousands of them. And these libraries introduce vulnerabilities. So again, I need to take care about these vulnerabilities. I also probably need to provide somebody with an SBOM and even validate the SBOM or make sure that it's stored so I can deliver it to somebody. So now I can introduce an SDA scan. I just included in one of the tools that's possible to do this. So it will scan for vulnerabilities. But then more complexities come. I might have infrastructure as code files called Terraform that configure my cloud, and they might have problems. And as I go and just make this more complex, I might have problem with plugins, and I might need to use a secrets manager to get my secrets across the board. And I'll just skip through here. I can make this graph extremely big with different requirements. So it could be the base image of the container. It could be the API that I'm exposing. It could be even the artifactory itself that actually just gives everybody access to the artifacts I have because I just misconfigured it. So the construct of a pipeline, and this is a very simple pipeline, can grow to become extremely complex. And in reality, the numbers are higher. So the dependencies within an organization are so complex that, again, there is the famous example we're using. We've got like this infrastructure project, which goes into everywhere. It's being built into a library. Everybody uses it. It gets into everywhere. And then one day there is a vulnerability in this infra project. There is absolutely no knowledge that this infra project is actually everywhere. And organizations miss that in many cases. And they miss, like vulnerable dependencies, they miss malicious dependencies. We had a call with a customer that said that they thought their pipeline was completely secure. They had the most secure process. They're a very, very important financial institution. But then they ran a red team and introduced a library, a malicious library into the process. So they simulated a typo squatting attack where somebody just misspelled a library and downloads a library that does, whatever it wants, and it compromised their data. And they said it was so simple. We were actually even sure this might happen in the past, but we just never took care of that. And this is just an example that there are so many requirements or so many ways this construct could be breached that I would want to do transition into why is it hard? And I'll actually start with the second bullet here. There is a very big knowledge gap. So what's the checklist? How can we know what is all the attack surfaces and vectors that we need to do? And I think in the beginning of this session, I think Gary said there's an increasing amount of requirements. Even AI now is a new frontier. So I'm developing an app with LLMs inside. How can I make sure I'm not just exposing sensitive data? So the knowledge gap is a very, very big gap, specifically in application security, about what did I do to create a secure SDLC. Other three gaps that I would like to cover is the visibility gap. So what is all the attack surface? So do we know all the code repositories? Do we know all the developers? Know all the third-party components? One problem today is that there are many, I'll call it marketplaces. So there are many repositories online which you can consume third parties from. It's not just open source. It could be built plugins that are being consumed and they do operations. It could be also, let's say GitHub Action. You rely on third-party actions to build your software. It could be, there are many areas where there's a third-party community and organization use third parties. And if you ask them, can you tell me all the things I'm dependent on, or all the things the organization is dependent on almost blindly? So, sorry about example, but let's say a kid comes back home somewhere in Indonesia, creates code, and this code now will run at some US bank production environment because they consume this third party. These are all things the organization doesn't know about. And there is a very, very big visibility gap, legit security as a solution. When we come to customer, this is what we specifically solve. And this is an area where we see a lot of demand for. We hear security teams say, hey, this is the first time we learned there is a Jenkins build server here. We never knew it existed. We never knew it's unpatched, and we never knew anybody with network access could just get all the code out. So there is a very big gap. We can talk a bit later. Maybe we'll have time also, why there's this big visibility gap. But the short answer is that engineering move very fast. It's cool. Usually the security teams, they're accountable for making this secure, but they're actually out of the picture sometimes. They're not involved in decisions, and they have to investigate their way into understanding what's going on. The third problem is the sheer amount of findings. So I think everybody will agree with everybody that has some experience in doing testing that more than 90% of the findings produced by tools are, I wouldn't say false positives, are not worth fixing. So they're either very not exploitable, there is actually no situation where the thing's going to be a threat, or it's, again, not worth the fixing, or even not relevant because there's been so much time in the past that even this vulnerability now, it's not part of any flow. And also false positive. It's not a real finding. So most of the findings today are noise. just think about a situation. We had a situation in my previous company where a static analysis tool created a finding that said MD5 is not a secure hash function. And then somebody used MD5 in their tests. And someone scheduled a meeting for 30 minutes with the team, like, why do you use MD5? And there was so much time wasted across the organization around this finding, which was completely not important. There's hours of people, went on trying to understand and explain why this is not a problem. And this is just one finding. If you think about the 100K average for most organizations and even more, then going on to all of them, this is almost is going to exhaust all the resources. And one of the problems is there is actually no good way of trying to find out what to do first. There's no context. There's no root cause. A lot of tools just dump tons of vulnerabilities. A fourth category of problems is that the infrastructure is insecure. And I talked about this before. There's secrets everywhere, sensitive data everywhere. And then bad hygiene. There's really estimation to good hygiene practices can lead to a lot. Like if you look at SolarWinds, again, they were hacked, like their build server was hacked, it was a nation state attack, but there was a lot of very, very small cases, like CodeCon, or their main binary was replaced and thousands of users ran a malicious version because their storage, artifact storage was hacked. So I would like to touch on this specific area that I highlighted and giving some 3 examples because I think this is an area that's often not being addressed, the area of the security of the build system. So I'll give 3 examples that we come across in many cases, which I think represent some of the most common areas that are not addressed. And we'll end this session with that. So the first one would be around secrets. So again, secrets, there is, as we go and do more cloud native development, we need more secrets. So you have to have API tokens and keys, and they're everywhere. You need to use them. If you're using like microservices-based architecture in the cloud with databases and services, there's a lot of permissions involved, and they have to be carried out of the application in some way. And third-party services. One of the common things that we see that happens is that somebody is testing something, so they write a secret hard-coded, then they delete it, and they just commit code without a secret. But they just forget that there is Git history. And then when somebody reviews the code, they review the latest change, they review the main branch, they say, oh, this code looks legit, let's merge it. But they're merging a history of changes which contain the secret. And hackers know that. Unless you're using you're squashing your Git changes, and this has not sometimes happened, there's a lot of secrets in history where everybody's convinced they deleted them. Everybody forgets that it's saved there forever. And most of the attacking tools just know how to dump the history. There's been a test, I don't remember who conducted it, but they released public code on GitHub. And the code with a secret, and it took less than 15 minutes for somebody to try and use its secret. So they put there a cloud key that wasn't accessible to anything, which just logs any attempts to log in. And it took minutes. So the internet is like sea full of pirates. The moment you touched it with a code that has secrets, there's a good chance the thing is compromised. And then it's not just in code. So one nice example that we saw, and we're seeing again, that same thing happens for instance, in this case, Atlassian Confluence, great system. People forget it has history. It's used for documentation pages. We conducted a search one time. We looked at documentation pages for many products. You can't imagine how many live tokens we found that they had in past versions that before they uploaded. So the same concept happened. Again, it's not a it's a mistake. It's an honest mistake because this is something that people don't think about. But it's when you're dealing with a lot of tokens and keys, it's very likely they'll end up anywhere. Second example I want to touch on is the security of the build process. And actually want to touch on a concept that's called pull request, which is the concept of you submit a pull request, and the pull request is malicious. So we found out that if you write your testing in a bad way, so you get a code submission, you write automated test on that. Let's say the test runs some command based on the submission, then the submission could actually take over. And this just takes anybody on the internet, if you're developing open source, to just submit a code change and then make the code change compromise the repository. So the security of your testing in some time could, like the way you test changes could lead to a compromise. The last point I'll touch on, and that'll be the last slide, is that we find out that artifact storages are insecure. So we did an internet search for a lot of systems that host artifacts for download. And we found out that 30% of the systems, based on some really big analysis we did, expose a CV, the private one. So if you're not using a SaaS service, let's say you're using even JFrog Artifactory, you're using Nexus or any product, and you make it available on the internet, there's a big chance it contains a vulnerability. So many of these are unpatched, and some of them even expose sensitive information they shouldn't supposed to expose. Technical data and other things that are just people forget to turn them off. So the CodeCov incident started like this and poisoned many accounts. But yeah, these are three examples I want to go over that represent some common problems in setting up your SDLC. I'll stop here and leave room for questions.
Liav, thank you so much. That was incredibly interesting. And I think what I really loved about the presentation, and it leads to my first question, and there's some questions in the chat, as well, is, where do you start? I mean, you did touch on briefly that, some vulnerabilities are just not worthwhile. What framework does, a practitioner use to make that determination given, finite resources?
Yeah, that's a good question. I think there's two things. First of all, there's solutions today that can help with that. But I think the first thing to understand is to just consolidate some understanding of what you have, which again, there's tools to help you do this, like classic asset management. Like, what do we have? How do we work? Doing this investigative work, what are the technologies we're using? How does the pipeline look like? And then matching this against some frameworks. There's like good frameworks out there, even secure software development framework, but just matching this and saying, hey, this is what we need. Like getting this checklist is important. If you're tempted by saying, hey, I'll just run an SCA tool, that's fine. You're probably either overkilling yourself in many cases or missing other important things. So getting something like a checklist of these are the, let's say, 30 things we need to take care about, then kind of like prioritizing them. Let's start with secure development permissions, and let's start with secure third parties. It's important, but getting this actual checklist, and it's worth the investment initially.
Just one follow-on question about the nature of the investment. I mean, one of the challenges that I think is widely known is, how to make a return on investment, sort of case to get budget, and especially this kind of disjoint between, experts such as yourself and the boardroom. How would you sort of distill what you're saying here to actually secure more resources?
If I understand correctly, then so how do you justify in an organization such an investment? So right. I think first of all, it's becoming more. I'll give a very bad example, like bad in sense of it's unfortunate example. but the CISO for SolarWinds is getting there's charges against this person, which again, you could agree with this or not, but I think it's becoming a matter of fact that organizations like executives in security need to know what's going on. They can't ignore it. They can't leave that for chance. So so that's like the first. This is like the first example. If you want to, like just do your duties and your responsibilities, but I think the common answer is that in investing in pre-runtime environment and fixing things here, or getting a secure by design pipeline, this is the best investment you can do, because you don't want to catch things afterwards. You don't want, like, eventually, there's a couple of things I'll touch on the next session, which more about a solution, but the most effective way to release secure applications is to build a secure by design operation. And this eventually saves time and money. Like there's many models that actually prove that it saves more money than you start by just detecting vulnerabilities in runtime or in the cloud security and then need to go back and fix it. So it's the most efficient way. And then just the number of, if you look at the incidents that are happening and the trends, this is a real attack surface.
Wow. I mean, there's so much more. You have a couple questions in the chat that you'll be able to, get to afterwards. But, thank you so much.